Hi, how's it going? Welcome to Code with Z. Today's question is LeetCode number 12, integer to Roman. And here we're basically given a normal number and we gotta convert it into Roman numerals. For example, if we have 3,749, we gotta return this. And if we have 58, we gotta return this. Now, obviously, there has to be some rules that we gotta follow, so we go from a number like this to a number like this. And we can see the rules here. As you can see, M stands for 1,000. So if we have 1,000, we gotta return M. D is equal to 500. So if we actually have 500 in our number, we gotta return D. And so on and so forth. As you can see, 100 is C, 50 is L, and 10 is X, and 5 is V, and 1 is I. However, we also have a bunch of edge cases that we gotta cover, and I've basically visualized everything that we have here in the coming slides, but for the sake of reading the question properly, I'll explain it shortly here, but I've actually visualized the whole algorithm and our plan for solving this problem, so you have nothing to worry about because I will not finish this video until I make sure you fully understand how to solve it. As you can see, we have a bunch of edge cases here, but the most important one for our solution is gonna be this one. This point is basically telling us that beside these numbers here, we actually have other numbers. For example, we have 4 that you cannot find here, or 9, or 40, 90, 400, and 900. And as you can see, for representing 4, we're gonna use IV. The V stands for 5, and I stands for 1. So when we say IV, we're basically saying V minus I, meaning 5 minus 1, which is gonna be 4. And the same goes for all of these. So for example, if we have D, which is 500, and we actually have a C before it, that's gonna represent 400 because we're saying D minus C, meaning 500 minus 100. As you can see, D is 500 and C is 100. But don't worry, in the solution that I have for you, it's gonna be so easy to implement all of these. Our code is literally like 5 lines or so. All right, let's solve this together. So this is the number that we're gonna visualize and show you exactly how we're gonna get to the results. This slideshow took me ages to build because I literally visualized all of the process, and I really hope you gain value from it. So in the beginning, let's actually start with a simple number, and then we're gonna go back to that number. So let's say our number or our num was 1,500. And this was given to us by the question itself. As you can see, M is equal to 1,000, D is equal to 500. What I've actually done is that I've actually ordered them from the biggest number to the smallest. But in the question itself, it was ordered from the smallest to the biggest one. So let's move this here to get more space. And let's say we want to convert this number that we have here into Roman numbers. So how are we going to do that? It's actually pretty simple. As you can see, we have 1,500, right? We literally say 1,500. And here we actually see that 1,000 is represented by M in the Roman numbers. So we can easily say for this 1,000 that we have here, we're just gonna add M, because 1M is equal to 1,000. But we still have a 500 here left over. And as you can see, 500 is represented by D. So we're just gonna add a D, and this is gonna be our number. As simple as that. As you can see, because we have this object here that has the symbols and the values, we can basically check which one of these values we have in our number, and we're just gonna return the symbol that's actually corresponding to that value. But what if we have a number like this? Well, as we saw, this object here doesn't represent all of the numbers. For example, we have 4, or 9, or 40, 90, 400, and 900. So we gotta find a solution for this problem. If we didn't have these numbers, our solution would be really simple because the object that we have here actually represents all of the numbers we need. But in reality, we do actually have these numbers. So how are we gonna calculate the Roman version of this number here? And what are we gonna do about these numbers? Well, you see, the solution is pretty simple. This object here was already solving our problem. The only thing it lacked was these numbers here. So why not just add these numbers inside of our object? If we just add these to our object like so, as you can see, 4 was added here, 9 was added here, same thing for 40, as you can see, then 90, and then 400, and then 900. If we add these edge case numbers to our object here, it's gonna solve all of our problems, and I'll show you how right now. That actually rhymed. So now I'll explain the algorithm and then I'll visualize the whole process literally step by step. So for our algorithm, we're gonna focus on this object here because it simply has all the solutions that we need. And then we're gonna define a variable called result. And this result is gonna contain the Roman version of our number at the end. And then we only need one loop. And we're gonna only have 4 lines of code inside of our loop, and it's gonna solve this problem. We're gonna actually create this loop by looping through the symbol and the values that we have in our object. You're gonna see this when I visualize the whole process, but inside of our loop, we're gonna have an if statement that says if number divided by value, which is this value here, is greater than 0, do the following. So each time when we're looping through these pairs, on each iteration, we're gonna have a value and a symbol, right? So we're gonna say if our number, which is this number here, divided by the value, is it gonna be greater than 0? For example, if our number here was 10 and our value was 50, 10 divided by 50 is smaller than 0. And that's because this 50 is bigger than 10. So when we divide 10 by 50, the result is gonna be less than 0. But if we divide 10 by 5, the result is gonna be greater than 0 because this 5 is smaller than this 10. So this is what we mean here. We're saying if the number divided by value is bigger than 0, do the following. The first thing that we do is define a variable called count, and this count is gonna be equal to number divided by value, literally the value that we have here. So for example, if our number was 3000 and our value was 1000, meaning we were here, we're gonna get 3 and count is gonna be 3. And you might say, why do we even need this count variable? Well, you see in this scenario, our count variable is 3, and it's basically saying that we have 3000s inside of 3000. Meaning, since 1000 is represented by m, if we wanted to represent 3000, we would just have to have 3 m's. And this is gonna represent 3000 in the Roman number system. And that's because, again, 1000 is represented by m. And because our count tells us how many letters we need to have to represent our number, we can easily get to the result. And you're gonna see the code version in the next line here. But imagine if we had 3500. When we divide it by 1000, it's gonna give us 3.5. And in reality, we only need this 3 here because this is telling us how many of these symbols here we need to have. And we gotta find a way to get rid of this decimal here. And for doing that, we're gonna use math.floor. This function here literally gets rid of that decimal that we don't need. Now for our next line, we're gonna say result, which is this variable here, is gonna be equal to itself plus the symbol. As you remember, 1000 is represented by the symbol of m. So if we have 1000 in our number, we gotta return m. If we have 3000, we need to return 3 m's. And this is how we're gonna use this count variable. Because we're gonna say add the symbol to our result here, but we might need to repeat the same symbol 3 times. And count is gonna tell us how many times we gotta repeat it, because as you remember in our example, 3000 divided by 1000 was 3. And this was our count variable, and because of that, we knew how many times we gotta repeat the symbol. We're literally gonna do the same thing. We're gonna say symbol.repeat of count, meaning if count is 3, repeat the same symbol 3 times and add it to result. These examples are just for explaining the algorithm because I'll visualize the whole process, so don't worry. And the last line in our code is gonna be number is equal to number mod value. You're gonna see how this works in the visualization. It's easier to explain it there. And then at the end, we're gonna return our result. This is literally our code. Now let's visualize it together. As you remember, our loop was created from our object because we were looping through each pair in our object. So the first pair is gonna be m, which is the symbol, and the value is gonna be 1000. We're literally looping through each pair as we go. So in our first iteration of our loop, our symbol is gonna be m, and our value is gonna be 1000. And as you see here, we're saying if number divided by value is greater than 0. So we gotta check. Number is 3749, so we have this here. And our value is this number here. We're gonna divide this number here by 1000 and it's gonna give us 3.749. And we're gonna get the floor of it, so it's gonna be 3. So as you can see, 3 is greater than 0. So we're gonna get inside this if statement. Here, our count variable, which is equal to the floor of number divided by value, which we just calculated here, is gonna be equal to 3. And then we're gonna say, repeat the symbol count times. So our symbol is gonna be m, because as you can see, our symbol is m here, and our count is 3. So we're gonna have 3 m's. And then we're gonna add these m's to our result, like so. Then we're gonna say number mod value, meaning 3749 mod 1000. And this is gonna be 749, because we're modding by 1000, and anything that's not 1000 is gonna remain, which is this 749 here. So we're gonna update our number, because we're saying number is equal to this, so our number is gonna be 749. And then we're gonna enter the next round, and in our next round, our symbol is gonna be cm, and our value is gonna be 900. Then we're gonna check again if number divided by value is greater than 0. So we're gonna say 749, which is our number, divided by 900, which is our value here. Is it greater than 0? As you can see, it's not. So it's gonna be false. This is not gonna be greater than 0, and we're not gonna enter this if statement, and we're gonna move on to our next pair. Our next pair is gonna be D and 500, and as you can see, 749 divided by 500, because number divided by value is greater than 0. It is actually, it's gonna be equal to 1.4. So we're gonna enter this if statement, and then we need the floor of this. So it's gonna be 1. We're getting rid of this decimal here. So count is equal to 1. And then we're gonna bring our symbol, repeat it count times, and add it to our result. Our symbol is D. Our count is 1. So we're gonna add 1D to our result, like so. Then our number is gonna be equal to number mod value, meaning 749 mod 500. And that's gonna be 249. How many 500s do we have here? One 500. And if we take that 500 out, we're gonna be left with 249. And then we're gonna enter our next round. In our next round, our symbol is CD and our value is 400. We're gonna check if 249 divided by 400 is greater than 0. It is not. So we're gonna move on to our next pair, which is gonna be C and 100. And we're gonna say, is 249 divided by 100 greater than 0? It is. So we're gonna say, how much is it? We're gonna say 2.4, because 249 divided by 100 is gonna be roughly 2.4. And as you know, we don't need the decimal, so we're gonna get the floor of it, and it's gonna be 2. So our count is gonna be 2, and we're gonna say, repeat the symbol, count times, and add it to our result. Count is 2, and our symbol is C, so we're gonna add 2 C's to our result. Then we're gonna say number, which is 249, mod value, which is 100. So 249 mod 100 is gonna be 49. And then we're gonna enter the next round, and our symbol is gonna be XC, and our value is gonna be 90. 49 divided by 90, and it's not gonna be greater than 0. So we're gonna move on to our next pair, which is L and 50. 49 divided by 50 is not gonna be greater than 0. So we're gonna move on to our next pair, which is gonna be XL and 40. Again, the same thing. We're gonna say 49 divided by 40 is greater than 0. It is. And it's gonna be equal to 1.2, and we only need this number here. So we're gonna get 1, and our count is gonna be equal to 1, and we're gonna add the symbol count times to our result. Our symbol is XL, and our count is 1, so we're gonna add 1XL to our result, which is gonna be this. And then our number is gonna be equal to number mod value, meaning 49 mod 40, and that's gonna be 9. Then we're gonna enter our next round. Our symbol is gonna be X, and our value is gonna be 10. 9 divided by 10 is not greater than 0, so we're gonna move on. In our next round, our symbol is gonna be IX, and our value is gonna be 9. So we're gonna check 9 divided by 9 is it greater than 0? It is, and it's gonna be equal to 1. So our count is equal to 1, and we're gonna add the symbol that we currently have and repeat it count times and add it to our result. Count is 1, our symbol is IX, so we're gonna add 1 IX to our result, like so. And then our number is gonna be 9 mod 9, which is gonna be 0. And then we're gonna enter our next round, which is gonna be V and 5. We're gonna check 0 divided by 5. Is it greater than 0? No, because 0 divided by anything, it's gonna be 0. So we're gonna move on to the next round. Again, same thing, 0 divided by 4, because our pair is gonna be IV and 4. And we're gonna check, is it greater than 0? Nope. Let's move on to the next one. I and 1. Is 0 divided by 1 greater than 0? Nope. And we're gonna break out of our loop and return our result. This was literally it. Now let's code this in the simplest way possible. All right, let's code this together. So first of all, let's define our result variable, which is gonna be equal to an empty string. And then we're gonna need our object, which is this thing here. And don't worry, I won't make you watch me type this out. I just copy pasted here. It's basically the same thing. It's saying M is equal to 1000, CM is equal to 900, D is equal to 500, and so on and so forth. Like so, literally just an object. And then below our object, we gotta loop through each pair in our object. For looping through each pair in our object, we're gonna say object dot entries, and we're gonna give it our Roman object, and we're gonna say for each pair that we have, do the following. So first of all, this pair here is gonna contain our symbol and our number. So let's deconstruct it together. We're gonna say const symbol and value is gonna be equal to pair, because this line here is gonna give us each pair that we have in an array, and we're gonna deconstruct that array here. We're gonna name the first one symbol and the second one value, and that's literally it. And then we're gonna simply say if num divided by value is greater than 0, do the following. We're gonna initialize our count variable, and we're gonna assign it to math.floor of number divided by value, just like we agreed on. And then we're gonna say result is equal to result plus our symbol dot repeat count times. So we're going to repeat our symbol count times and add it to our result. And then we're going to write our last line in our loop, which is going to be num is equal to num mod value, just like we saw in the previous slides. And then after our loop, we're going to say return our result. And this is literally it. This is all of our code, as you can see. Now let's run it. Moment of truth. Let's see if we're going to pass our tests. As you can see, it passed all 3. Now let's actually submit it and see if we're going to actually get accepted. Moment of truth. As you can see, accepted. Thanks for watching. Don't forget to like and subscribe and keep on coding.